I would like to thank the organizers for the opportunity to talk to a good, diverse group of clinicians. What David actually asked me to focus on is the role of sex and race differences in visceral fat and cardiovascular disease. I push a green button, big green button. I found it. So I think it's important to point out that, as the previous speaker did as well, that there are different obesity types, and not surprisingly, they are different in men and women. I think it's important to remember that women can be either with most of their fat in the upper body or most of their fat in the lower body. Approximately half the women in the world have an upper body obesity predominantly, or even upper body fat distribution. I shouldn't even say obesity. And the other half have a lower body fat distribution. Men also have, surprisingly, there do exist male pairs, but on average, men have less fat in their thighs and below the waist. This is not a matter of cosmetics. This has a very clear biological consequences, as we've sort of heard. The question that I've been asked to address is whether it's race dependent and whether it's sex dependent. The answer to both those questions is yes, and it has major effects and influences prediction of cardiometabolic health. So just a very basic thing. I actually had to go back to an old study from Jean-Pierre Dupré, who did a cross-sectional study of healthy young individuals and looked at the amount of visceral adipose tissue, which is on the y-axis, against, he did it against subcutaneous adipose tissue, which I'll point out is 85%, sometimes 90% of the total fat in the body. So it's obvious that the men in the blue have more visceral fat for a given amount of total adiposity or total SAT. And the most important thing to remember here, has been said over and over, is that greater visceral adiposity identifies more cardiometabolic risk, even in normal weight, normal, non-obese, apparently healthy subjects by standard clinical criteria. I think it's also important to point out that men, compared to women, have more, not only more visceral fat, but more epicardial and pericardial fat. So why is this important? There have been prospective studies. The odds for a man or a woman developing type 2 diabetes is twice as high in proportion to a larger waist, if they have a larger waist. It's literally lower, attenuated by having more fat in the lower part of the body, in the hips and thighs, so the gluteal and the thigh fat, which is intriguing mechanistic question. It's also important to point out, obviously, to this audience, that peripheral adiposity is protective as well for future metabolic and cardiovascular disease. As you can see in the study, it's the odds of developing cardiovascular disease. Again, lower body fat protective, upper body fat accentuates risk. And finally, the one endpoint that I think we can all agree on how to diagnose, which is death. And again, I am a basic scientist, but I know that. Waist circumference is positively correlated in both sexes. This is attenuated by those, the rightmost two graphs, with a higher waist-hip ratio. And so it's important to remember that this occurs after adjustment for BMI. So it's independent of BMI. In what appears to be a normal weight, normal BMI person, you still have this influence of body fat distribution on health and lifespan. It's also important to realize that there are genetic determinants of this. There are genetic determinants of leg fat, fat in different parts of the body. Literally every depot is developmentally distinct. They have different gene profiles, and they are functionally distinct, both for the secretory function of fat and for the metabolic role of fat. So again, in this study, there is a race difference. The risk of type 2 diabetes among Hispanic Americans clearly has a genetic basis, and it's related to the inability to store fat in the lower body, in the thighs, and the gluteus, actually. So that's very interesting, and that does vary by ethnicity and race. The bar on the right are the Hispanic participants, and adjusted for everything and its mother, it still exists. So this is, I just thought I put this slide in. It's a study that looked at fat distribution in individuals of different races from many different countries across the world, from Arab people, Mexican, Asian, Black Americans, Hispanic Americans, Caucasians, from different parts of the world. And you can see from what is plotted here, which is leftmost shape is arm, then legs, then trunk. And it's sort of very obvious, which is essentially a violin plot, is that this varies by race. So, is there a race difference? I must say, many years ago, we undertook comparisons of Black compared to white individuals at what's now Mount Sinai Morningside. It was Columbia then. Black women have less visceral fat for the same waist to hip ratio, less, yet they are at higher risk. That means, obviously, that race matters, and race is an independent predictor. It varies by the race effect is there, independent of body fat distribution. There are also sex differences, which in insulin resistance, which we measured directly. And there are studies that say there are also sex differences. The bottom right graph shows that men are less insulin sensitive to the most important action of insulin, which is to inhibit lipolysis. If you inhibit lipolysis, you don't have excess fatty acids going to other tissues in the body, which is illustrated on this slide, which is very hard to describe without pointing to it, but I will do my best. The upper left-hand person has a lot of visceral fat despite his general leanness. That visceral fat drains into the portal vein both fatty acid and adipokines, which are hormones and anything else released from adipose tissue. It goes directly to the liver. Not amazingly, this is related to hepatosteatosis. It goes to skeletal muscle, the vasculature, kidneys, and heart. In heart, we also have a very local effect. In contrast, the other abdominal fat, in terms of flux of fatty acids, is the greatest flux to the systemic circulation, which is distributed then to all the other organs in the body. And on a weight basis, gluteal femoral fat is less. It has less of an effect. Combined, if your fat distribution is different, this is why you get ectopic fat distribution, as was pointed out both within and between fibers of skeletal muscle. And you also have very clear effects in the heart. Apparently, on CT scans, you can see the fibrosis in fat, in dysfunctional fat. You can see different qualities of the density of fat, which means that we can get more refined in how we diagnose. Thank you very much for your attention.